Okay, so one more in Marine Parade and one more in Bukit Timah. For myself, I primarily teach in the East, even though I stay in the West, but I do have J1 classes in Bukit Timah as well. Okay, just to share. 3 more locations, Toa Payoh, Jurong East, and Woodlands. Actually, in the notes, you can actually see the second page. There's a picture with the tutors that teach math for OVERMUGGED. We are all stationed at different places around Singapore. So that is how we split our job scope lah. So for me, unfortunately, I drew the short end, and I'm teaching in the East when I stay in the West. Okay, so who am I? Okay, so my name is Kaiwen, and I have been teaching for about 6 years already. And my background is I studied math in uni. That's the thing that I proudly tell people, that I studied math in university. Okay, so I'm one of those weird people that studied math. Okay, so why? Because I love math a lot. Okay, so if you're planning to pursue a career in mathematics, planning to go into uni, take math, my answer is don't. Okay, go for other things. There are way better things out there, unless you're xiao like me. You know the people there. You know the people in my photo. I just anyhow throw photos. Hello. Yeah, anyway, no problem. Okay. Okay, so what are we doing today? So for today, right, the main goal is to go through the 2 chapters, which is functions and graphing technique. I'll spend more time on functions, and then graphing technique, I want to spend more time on 1 over fx, and I want to give you more time to try the questions. That's why I prepared some questions at the back. Okay, so without further ado, let's begin. Okay, so you see in front of you, there are 3 sets of notes, just to tell for those that were slightly later. Okay, in front of you, there are 2 sets. One is session 1 and session 2, both with the picture of the astronaut holding the balloons. Okay, session 1 is the functions and the graphing techniques notes. Session 2 is differentiation. Now, there are plans right now that I'm taking out of my own personal schedule again. Next week, the Monday of Teachers' Day, I'm planning to open up 2 more sessions for vectors. Okay, because I think vectors is very, very highly demanded at the moment. So if you are interested, when the link goes up, go and ASAP, go and book lah if you want to get a session for vectors. And they will be online, of course, if you cannot get it. Okay. So this is the team that teaches math. So let me share who we are. Okay, the fattest one there is me. Okay, that is me. I teach both O levels and A level math. The skinny guy in the center, that one teaches A levels at the west side, and the girl teaches O level math. So for me, I teach both lah. Okay, because of my background. So what is this? Okay, this is a free thing that we are giving out for us math tutors, is that we are giving out free questions for you to go and practice. So I know your schools have been giving you revision packages and everything. For us, what we did is we went to search out for some of the more messed up questions from different schools, especially for schools that are more messed up. We'll choose those questions and we will put them out for you to go and try. But just take note that this is still not ready at the moment. End of the week, we will put it inside here. Okay, so give us some time. Promise it will come. Last thing, there are questions at the back of this set of notes which we will be touching. These questions, the answers to them will be also uploaded here 1 to 2 weeks time. Okay, so give us some time. Promise it will come out. Okay, must give us some time. Okay, and without further ado, let's begin with functions. So for me right now, I'm going to talk very, very quickly through the functions topic. And then I'm going to give you some time to try, and we'll also run through some of the questions together. So let's start off first with functions and what are the important things that you need to know and some of the more critical points that you need to remember when doing this chapter. So you need to understand how to use all your set operators well, your unions, your intersections, your takeaway symbols. How do you use them to express your answers? The interval notation is super important as well. I think this is something you already know. If it's a square bracket, this is an inclusion. If it's a circular bracket, this is an exclusion. So these are important things. For example, when you're writing your domains, when you're writing your ranges, you must use the correct brackets. So be careful, don't make careless mistakes here. For the infinity symbol, remember that infinity is an idea. It's not a mathematical number. You have to use brackets. You cannot use you have to use the circular brackets. You cannot use square brackets. You will get it wrong. Okay. Super simple concept. Okay, let's move on. Now, let's talk about relations and functions. So 2 things. This first box here that you see in black, compared to the one below, they are very different things. The one on the top is what we call a vertical line test. The one below is a horizontal line test. Now, certain schools do not teach your vertical line test. I think if you come from a more messed up school, they will teach you vertical. But if they don't, then you can ignore. Okay, but what is a vertical line test? Basically, we are testing whether an equation, is it a function or not? Because not everything is a function. So I give you an example. If I draw you a curve that looks like this, is this a function? No. The way to test is this. We draw a vertical line through this curve, and since this vertical line cuts through 2 points, this is no longer a function. Hello, Evan. Understand? You will be tall, so you see corner. Yeah. Okay, so so this is the definition of what is a vertical line test. It is to test whether something is it a function or not. The one that most people know is about the 1-1 function. How do we test whether something is 1-to-1? Now, let's say if you are not sure why is it called 1-to-1, your school never explained to you, just think of it this way. When I input one value of x, I should output one value of y. It's a 1-to-1 exchange. That's why it's called 1-to-1. Understand? So how do we test for 1-to-1 functions? For example, if we have a curve, we draw a horizontal line along this curve, and we can see that there is only one intersection point. Now remember, in exams, you do need to state the equation of this horizontal line. 2 ways of writing. Number one is either you state the value that will give you one point of intersection, or you say y equals to k, where k is a certain range. Understand? So 2 types. Personally, for me, I will sub-value. It's faster. Sometimes k, if you mess up your range, you will get it wrong. Okay. Can you do me a favor? Is the door on the outside open? It's open. Can you help me close? Thank you so much. The main door. This one is okay. The main okay, very good. Thank you. Okay, so the next thing we'll talk about is inverse functions. So the condition for a function to be an inverse, okay, is that it must be 1-to-1. Thank you. Okay, it must be 1-to-1. You must check whether your functions are 1-to-1 before there exists an inverse. I believe everyone knows how to find an inverse, which is to make x the subject of your equation. But remember, there are certain cases where it is impossible. For example, if I give you cubics, if I give you things that are very disgusting, sometimes it is not possible to search out for the inverse. There are other ways of doing it. Usually what we do is we draw the graph. So I'll show you a very quick example. If I give you a graph that looks something like that, how do you find the inverse? Okay. So we all know that it is reflected about the line y equals to x. So literally do a mirror image. You might not be able to find the equation, but you can see what the graph actually looks like. So I have a student last time, actually this year, she shared this pretty cool technique of how to draw inverses questions. I think it's pretty cool. So what she did was she drew the normal graph first on a piece of paper. You draw the line y equals to x. And what she did was she folded the question paper. She folded it along that line y equals to x. And then you put on the paper, you see your pencil mark. Through the paper, you trace. Your inverse will come out. It's pretty cool. You can go and try. See whether does it actually work or not. But I'm pretty sure it does. Okay. The next thing, this is important. The domain of the f inverse is equals to the range of f, and the range of your f inverse is equals to the domain of f. Okay, this is things you need to remember. Okay, let's look at it visually. How does this work? This is your domain. Okay, this is your f of x, of course. This is your range. This is the range of your f inverse, and this is the domain of your f. Okay, so this is how the graph looks like, and how is it related between f inverse f, domain, and f inverse and f. Yeah. Okay, very good. Now, we all know that the graphs are reflections about the line. Okay, I want to say some things about this particular concept here. There are differences between drawing the line y equals to x and y equals to f inverse. Okay, let's talk about the difference. You only draw the line y equals to x when the questions say show relationship. Okay, there is also a difference between a dotted line and a solid line. Dotted lines are meant to show relationship. Solid lines are for you to express the equations themselves. Understand the difference? We only use solid lines when we are defining your FF inverse. These are always solids. These are always dotted. Understand? Last thing that is very important, you must be careful of the way you draw your FF inverse. You must restrict your range and your domain of your FF inverse. You cannot just anyhow draw the whole entire line because you need to follow the domain and the range of the question. So how do you tell? Very simple. Let's say if I give you y equals to FF inverse and I ask you to draw this particular function, where do you know where to stop? How do you tell? Remember the rule. This is a composite function. The domain of a composite function is equals to the domain of the second letter, correct? For example, the domain of GF is equals to the domain of F. It's the same thing here. The domain of your FF inverse is equals to the domain of your F inverse. So that is where you stop your F inverse graph or your FF inverse graph. Understand what I'm trying to say? You do not draw the whole entire thing. You follow the domain of your F inverse graph. Before I continue, any question? This is important. So any questions? Don't know if your school got say lah, but this is important. Okay. Okay, very good. Any questions before I move on? Actually, I want to go around also ask what schools people are from. I want to know who from messed up schools. Okay, so last one before we start questions, we talk about composites. Now, how do you tell whether a function is it a composite function or not? You need to remember the range of your second letter is equals to the domain, or it's a subset of the domain of your first letter. So when I mean first and second, I mean this is the second letter and this is the first letter. Okay. Next thing that is important, the domain of GF is equals to the domain of F. This is important. When you see F squares, okay, so what does this mean? So this kind of questions here usually are those that test together with self-inverse. Okay, I hope your tutorials in school have gone through what are self-inverse questions. You should be experienced in this kind of questions. If you're not, it's okay. So what's an example of a self-inverse function? It's basically whether F is equal to the F inverse. That it means self-inverse. Okay, I cannot give you an example now. Later at the back, we'll look at the question together. So F is equals to F inverse of X. So the questions that will test this concept here is this. For example, I want you to find the value of F to the power of 2021. How do you solve these kind of questions? So the strategy is this. Remember, when I say F to the power of 2021, I mean F, non-stop. But because we know that there is self-inverse, we're going to replace every either odd or even F's with F inverse. And essentially what has happened is we cancel, because this will cancel with this, this will cancel with this, this will cancel with this, this will cancel with this. And then you go on and go on and go on and go on and go on, and then you realize they are just left with F of X. Understand? Or I can understand why is it F of X? Because there are 2021 copies, every 2 has been paired away, so it means you're left with 1. Simple enough. Okay, this is experience. You need to be able to do this. Now, let's say if your functions is very bad, or in general, if your H2 math is very bad. Okay, there is a way to get better at it. There's an 8-letter English word that starts with the letter P. Anyone knows the word? Can I repeat again? How do you get better at H2 math? There is a way. Okay, it's an 8-letter word that starts with the letter P. Practice, correct. Thank you. Okay, practice. You need to drill. No choice on. Okay, this is something I tell my students all the time. I should make a t-shirt that says that. Okay, but yes, okay, that is very important. The last thing, everyone's favorite question, find the range of a composite function. Okay, how do you find the range of a composite function? For me, I have a very visual way of doing this. So I'm going to demonstrate to you how I like to do it. So, for example, if I'm going to find g of f, okay, so let's say I need to find the range of this function. So first thing, usually questions will say, can you prove that this function exists? So how do we do that? We find the range of f is a subset of the domain of G. Agree so far? So what I like to do is this, okay? This is going to be a bit different from how schools teach it, okay? But if you like it, then you can see it. Okay, I'm going to draw a rectangle that looks like this, and this is my domain of G. I'm going to draw a smaller rectangle at the bottom, and this is my range of F. And what I'm going to do is this. They always say restrict the range of F to the domain of G. Now, if you cannot understand, look at this visually. This means that you just, like that, you chop away these pieces that you do not want. This section in the center down here becomes my new domain. So no matter what my range is, for example, if my range is 0 to 5 for your F, means my new domain will be 0 to 5. Okay? The next step is this. You draw the G graph. So you draw this graph within this new domain and then find the range. And we're done. That's how you do the whole question. Okay, if you prefer mapping, you can go ahead and do. It's the same thing. It's just that this is a more visual way to imagine the whole process. So if you're a visual person, this is a lot easier in my opinion. Okay, or there are a lot of different schools teach different ways. Like I think if you're from ASR, your school teach you the fishball throw down machine, then shoot out another fishball. Then got one school is like you shoot arrow to one place, then shoot back another arrow. Don't know, a lot of rubbish. Okay, so whatever school teach whatever way, okay, you just follow. Okay, it's the same idea. Okay, we're done. Okay, this is functions. Okay, now it's your turn to try. Okay, so it's your turn to try. Basically, it's just that. So at the back of this set of notes, I think it's page 21. I forgot the page number, but I think it's page 21. Okay, so we look at certain questions. We start from non-messed up school to messed up school. Okay, so we start with a non-messed up school first. We start with ASR. So question 1, please try. There's foolscap inside the, if you want iPad, foolscap or whatever, there's foolscap in the bags. Okay. Meanwhile, I'll go around and ask what school you're from. What school are you from? Yes, okay, nice. What school are you from? Okay, school? Oh yeah, Hua Chong. And why? Hua Chong. I know already. The two girls behind, what school are you guys from? JP. The guy I know. The two girls at the back, what school are you guys from? Why? Okay. Is it true the ASR they teach the fishball one? Correct, okay, I'm correct. Okay, so question 1. Okay, so please try. If you're fast and your functions is very good, look, the next question I'm interested in is 5. Watch out. But we slowly progress from normal school to messed up school. We slowly progress. Okay, so normal school first. Okay, question 1 and question 5. Do you need a GC? Do you need a GC? I have. Yeah. Wow, you go exam without GC, you tell me how you use it.
Recording in progress.
Okay, so I want to look at 157. So we start with ASR, Hwa Chong, then I don't know what's good. Okay, let's go through question 1 in 4 minutes. So let's go through question 1. It's okay if you haven't finished. Okay, just slowly. So we start from question part 1 first. We need to show that the composite function of fg exists. Okay, so to show this, we need to find the range of g. And the range of g, I'll just give you the answer, 1, 8. Okay, excluding 1, including 8. For your domain of f, this should be the real line. Okay, then you just explain, since the range of g is a subset of the domain of f, therefore, we know that fg exists. Okay, proven. This is the answer for part 1. And now we need to find the range. Okay, before I give the answer, does anyone have an answer for this? What is the range of fg? Before I randomly point. What is the range of fg? Hello? Okay, I randomly point at people already. See? Oh, I randomly point at everyone, look down. You? The range of fg. Cannot. Cannot. I don't know. And you? Don't know. Oh, okay. You? Don't know. You? Hello? Okay, then moving on to the back. Continue. Answer. The two girls. Don't know. My student. Don't know. The two girls at the back. Ah, no one knows. Excuse me. That guy. Don't know. Ah, it's what? Okay. Okay, slowly. It's okay. It's okay. Okay, so how to do? We start off with the domain of f. Okay. Now, if let's say you're not confident of telling me your answer, the answer is this: negative 18, 49/4. Okay, so how do you get this? Now, the domain of f is equal to the real line. The range of g is here. So range of g, it becomes 1, 8. So this visually, okay, this is your new domain. So the domain of your fg graph is 1, 8. What you do next? Draw the graph. So draw this. So let's draw the graph of f. So how does your f graph look like? Your f graph should look like this. Y, x. Now we label the endpoints. We know that here, this is a in exclusion. Okay, this is 1, I forgot what's the value. 1, something. Okay, not very important. Here, this is an inclusion of 8 and negative 18. And then you find this point, which is 49/4, I think. 5/2. 49/4. So this whole entire thing, this is the range of your FG graph. Okay, that's why the answer is just from negative 18 to 49/4. Okay, can this answer? Can you understand? Okay, wait, one round, the 4 in front. Okay. Cannot. I can explain again if cannot. Okay, explain one more time. Okay, so what you do is this. Listen carefully. You start off first with the domain of f. You write down the domain of f, which in this case is the whole entire real line. You write down your range of g, which in this case is 1, 8. Okay? What you're going to do next is you're going to restrict, that's why there's a dotted line, restrict the range of g. So this 1, 8 becomes the brand new domain of f. That's what it means. This thing here is the brand new domain of f. So this is the new domain of f. Okay, we draw the f graph. So what you do is you plot the f graph into your GC, and you should see something like this. And remember, you need to draw between the domain of 1 and 8. That's why I stop at 1 and 8. And the graph looks something like this. Next, what you do is you find the range. So range is from the lowest point to the highest point. The lowest point here is -18, which corresponds to your 8 point. And the highest point is your maximum point for this particular case. You need to find the maximum point, either use your GC or complete the square, and you can get your answer. How you get -18? Sub into the graph. So you sub 8 into f. So f of 8. Sub in and solve. Understand? Okay, so this is how to do it. Okay, for those that still cannot get it, which I think is like everyone, can understand now what I'm doing? Okay. Any questions before we move on? How to get the range of G? Like how I get the 1, 8, is it? Oh, okay. So the question tells you that you are going between x is greater than 0, right? So what you do is you plot your graph on the GC. You plot this onto the GC, and then you will see that there's an asymptote at 8. You need to plot the graph. Another way to look at it is this. Another way, okay, if let's say you have problems finding the range of G even, okay, you can think of it this way. The lowest point is 0. When you sub in 0, is 1 plus 7e to the power of -0, which is 1. That's the lowest point. For the highest point, we know that it pushes to infinity, right? So 1 plus 7e to the power of -infinity or whatever, right? E to the power of a really, really huge number approaches 0 or 1. Approaches 1. For this, it's 1. So it will be 1 plus 7 is 8. If you see your graph, right, your max, your asymptote is going to be there. Okay? That's how you see it. Next is part 2. Okay, so part 2 is also slightly harder. Okay, how do you get part 2? Okay, part 2, I just straight away go through. It is now given that the lambda is a real constant that is not necessarily equal to 5. If the domain of f is restricted to x is less than or equals to lambda over 2, find f inverse in a similar form. So what you need to do is this. We have f of x equals to 6 plus lambda x minus x squared. Okay. So the first thing you need to do is you need to find what is this equation in terms of x. So this means you need to make x the subject. And how do you make x the subject? Complete the square. So we let y be equals to, pull out the negative sign, x squared minus lambda x plus 6. Sorry, which is negative x minus lambda over 2 squared minus lambda over 2 squared plus 6, which is just negative x plus lambda over 2 whole entire thing squared plus 6 plus lambda squared over 4. So far, okay? And now we need to make x the subject of the equation. So we'll rearrange this. We get x equals to lambda over 2 plus minus the square root of 6 plus lambda square over 4 minus y. So the question is this, which do you reject? Positive or negative? You reject the positive or negative? Positive, yes. Okay, you reject the positive answer. The reason is because, so we reject the positive answer. The reason is because the question tells you the x must be less than or equals to lambda over 2. This is from the question. Okay, and now you're ready to write F inverse. Okay, remember you need to write in similar form, so you need to do the mapping thing. Lambda over 2 minus the square root of 6 plus lambda square over 4 minus x. Okay, now is the interesting thing. What is the domain here? What is the domain of your F inverse? Okay, if you cannot see it, look at it conceptually. The domain of F inverse is equals to the what? Conceptually first. Range of F. Okay, so what is your F graph? This. You agree with me that this is a hyperbola? No, this is a parabola, a quadratic curve. So how do you find the range of a quadratic curve? It's from the, this is what kind of graph? Set face or happy face? Set face, right? Because the coefficient of x squared is negative. Means it's going from negative infinity all the way to 6 plus lambda squared over 4. Correct? Do you agree with me that the max point is negative lambda over 2 comma 6 plus lambda squared over 4? So what is the domain, which is the range of your F, which is basically just x is a real number, but x must be less than or equals to 6 plus lambda squared over 4. And that's the answer. So before we move on, just any questions from anyone? Okay, just want to clarify something. Just want to check. This part, the domain of F inverse, can understand how I get the answer? Okay, the thought process. Okay, remember it's just to find the domain of the inverse is always to look at the range of the original function. In this case, the range of the original function is a quadratic function. So that's why it's to the maximum point. Okay, and how I know it's a max? Because it's a set face curve. Okay. So let's look at another one. Okay. Since everyone is very good at functions, let's not do the Hwa Chong question. Let's do 7. NYJC. Okay. Take about, how many marks is this question? Okay, take about 7 minutes. Please try. Is it okay if I spend more time on functions than graphing technique? Does anyone desperately need graphing technique? Other than 1 over fx? That one I'll do. Other than that. Don't need, okay, we spend a bit more time here. Because I think everyone's vectors, everyone's functions very strong here. So let's do it. Okay, we check answer for part 1 first, so that in case you're going down the wrong track, you know where to stop. K is, what's K? Yes, 0. Okay, K is 0. Okay, if you cannot even get K equals to 0, it is less than few days to promos, so please be a bit scared. Okay, if you want to see the answer for the part B, this answer. Agak-agak lah, agak-agak. This should be the answer. Let's see, does anyone have an answer? Anyone got an answer for part 3? You answer? Yes, correct. That's just 1. Okay, the answer for part 3 is 1. So how do you do this? So very quickly, just go through. So the question asks you to consider finding FG. So there's a reason why. Later we will talk about it. So let's find that first. So FG of x is a composite function. So this will be 1 over x squared plus 1 over x squared plus 1. Yep, correct. And this can be simplified down. Now, this is your algebra skills. This will be simplified into x squared over x to the power of 4 plus 3x squared plus 1. Okay. Now, how do you use this? Okay, let's say if you're unsure about how to use this, just go back into secondary school. We talk about this concept. Last time when we tell you sine theta equals to half, you want to find theta, it's just sine inverse of half. Do you agree? So this means the reverse process law. You can quote unquote uninverse it. So let's uninverse it. We get fg of x equals to 1 over 5. Okay. So this means that this whole disgusting thing here is 1 over 5. So therefore, 5x squared equals to x to the power of 4 plus 3x squared plus 1. X to the power of 4 minus 2x squared plus 1 equals to 0. X squared minus 1 whole thing squared is equals to 0. X squared equals to 1. X equals to plus minus 1. Now for this question, should you reject the positive answer or the negative answer? The negative. Okay, the reason is because we are talking about the g of x. So you need to follow the x is greater than 0. So you need to reject the negative answer. Therefore, x equals to. Okay. It is, but because the question asks you by finding fg x. There's otherwise, right? Yeah, correct. So there's an or otherwise as well. There are 2 ways to do it. There are 3 ways actually. So this is the following the question method. There's the words or otherwise in your question. So if your or otherwise method is to find the inverse, also can. Okay, whichever works for you. But if the question never say or otherwise, means you need to find FG. Okay, so let's look at one more. Okay, and then we can end for functions. We go back into the question 5, the particular one I want to look at. For Hua Chao. Okay, so question 5, the whole entire question. Please try. We will go through. Okay, you cannot do part A. And you need the B value. Anyone? What's the value of B? Anyone? B value? Yes. Correct. -1. Okay, the B value is -1. So if you need help showing this, there are 3 different ways. I will show you one of them. The other 2, you can read the answers. So what I will do is to find the inverse. 3xy plus by equals to x plus a. Let's make x a subject. So x 3y minus 1 equals to a minus by. X is equals to a minus by over 3y minus 1. So this will tell you that the G inverse of x is equals to a minus bx over 3x minus 1. Now we tell you that this is a self-inverse function. So self-inverse means that this is equals to this. So by comparison, by observational skills, you can see that b is -1. And to find a, we can equate the numerator. A minus bx is equals to x plus a. You're given a point, which is g1 equals to 5. You can use that to find the value. Okay. Use g of 1 equals to 5. Therefore, a is 9. As in the other ways. This is just one way. Another way is to do long division of gx. That's another possible way. Another possible way as well is to sub. We know that g of 1 equals to 5. We can sub it in. We can see that 1 plus a over 3 plus b equals to 5. A minus 5b equals to 14. We know that this is a self-inverse function as well. So means the g of 5 also equals to 1. You can repeat the process. 5 plus a over 15 plus b equals to 1. A minus b is 10. Simultaneous. This and this. This is another possible way. Okay, and the last way that you can do this, which I think is a bit more extreme, you can rewrite g of x using long division, and you can get 1 over 3 minus b minus 3a over 3x plus b. Now, the question tells you that, what's the question? X must be greater than negative b over 3, right? So there is a horizontal asymptote. Okay, we know that this here is a horizontal asymptote. Now, because this is a self-inverse function, this means that y equals to 1 over 3 is also a vertical asymptote. Because it's self-inverse. So this will tell you that 3x plus b, you can solve that, okay? Because you can use this fact. you can get that b equals to -1 as well. And then you repeat the process, you get a equals to 9. 3 different ways of doing it. All can. Anyone got a different way? Next is part B. The question is asking you to find what is g to the power of 2021 of 1. Okay, this is a very simple question. What's the answer? 5. Okay, the answer is 5. Simple reason is because we already know that g of x equals to the g inverse of x. So like I said just now, this is just g. Okay, take the g, put into g inverse, take the g, put into g inverse, take the g, put into g inverse, and cancel. So everything will cancel, and you're just left with one copy of g, because even numbers, you're left with the g of x or g of 1 in this case, which is just 5 from the question. Oh, okay, for the second one, someone asked why is this true? Because self-inverse. That's the reason why. Because if 1 maps to 5, 5 also map back to 1 if it's an inverse. That's the reason why. The next one is C, okay, which is the composite function part. So we are given a function h of x is defined by the following: 1 minus the mod of 1 minus x and x plus 5, which goes for x is greater than or equals to 2. So we know the question tells you that x must be greater than or equals to 2. Correct? This is a condition for the question. So looking at the modulus part, what should this modulus part be? Should it be mod of 1 minus x? No, this can be rewritten into x minus 1. Okay, understand? For all possible values of x greater than 2, the mod section will be rewritten as x minus 1. And you need to change out the mod because you need to solve for it. So now we have h of x equals to x minus 1, x plus 5. Okay, wait, before I move on, are you okay? Okay, okay. So the modulus part, can I understand why? Need me to explain again? Don't need that. Okay, it's because, okay, maybe just very quickly, mod of x is the same thing as piecewise 1 minus x and x minus 1. Okay, then you look at the values. X must be greater than or equals to 2. So it means you need it to be all positive. So it must be the second one, definitely. We're going to solve this equation here. Okay, and we need to find x, of course. So we need to make x a subject. So y equals to x squared plus 4x minus 5. You can choose to complete the square. Or in my answers here, what I did was the quadratic formula. It's the same thing. -4 plus minus square root of 16 minus 4 times -5 minus y divided by 2. Okay, which you will get -2 plus minus square root of 9 plus y. Okay, if you're wondering how I got that, I rearranged this into x squared plus 4x minus 5 minus y equals to 0. We got this equation. Now, the question tells you that x must be greater than or equals to 2. So it means we need to reject the negative answer. So therefore, x must be -2 plus the square root of 9 plus y. So you can rewrite h inverse of x to be the square root of 9 plus y minus 2. And what's the domain of your inverse? Is the range of your function. The value will be 7. That's the answer. Now, let's extend this question by one more part. I just want to ask something before I do the composite part. I want to ask something first. So the question is this: how do you solve? Okay, in general, just a general statement. If I ask you to find f of x equals to f inverse of x, how will you solve this kind of questions? Assuming that you cannot find the inverse. How do you solve this kind of equation? Assuming that you cannot find the inverse. Yeah, very good. Okay, just fx equals to x. Can you understand why? Because if you plot the graph, I should draw it for you, by x. Okay, no matter what your function looks like, it doesn't matter. Okay, wait, no, cannot. Must be. Okay, we can see that the entire graph cuts at the same point, y equals to x, and the two graphs intersect at the same location, and that is why you can just equate fx equals to x. Okay, this is another very, very popular question out there that they usually test for functions. Okay, one more, just to extend before I go through the last part. I need a white space. Okay, I'll draw for you something on the board. This was from TM. Okay, yeah, TM. TM JC William 2017. This was an interesting question that came out. But it's very simple, but interesting. So the question is this. I'll give you a graph that looks something like that. Okay. This is C1, C2. I'll just randomly choose a point, 1, 2, it doesn't matter. And this is 2, 1. Now, I tell you that C1 is a reflection about the line y equals to x, and it gives you C2. The question is this: is C1 the inverse of C2? Or is C2 the inverse of C1? Okay, I repeat again. So on the screen here, you have two graphs, C1 and C2. I tell you that C1 is being reflected along the line y equals to x, and you get C2. The question is C1 an inverse of C2? Yes or no? For 1 mark, and explain your answer. Yes or no? Yeah, we raise our hands up. Yes or no? If you say yes, raise your hand. 1 person. 1 person. Okay. If you say no, 1 person. The rest? Don't know. Yeah, the answer is no, it is not. Okay, why? Because remember, the condition for it to be an inverse is that it must be 1 to 1. The condition is not that it must reflect. Because the question only tells you that it reflects. It's not a condition. It just so happens that it reflects. So what? Doesn't mean anything. Okay, so this is just testing concept. Understand? Okay, and the last thing before we move into 1 over fx will be the GH graph. Okay, so let's plot. Let's show that GH exists. So for part C part 2. Oh, and another thing. For those from messed up schools, you take note, your schools always love to test piecewise. You know what's piecewise functions? is those that keep on cycling. Like for example, they give you f of x equals to 2 half, like x plus 1, x squared plus 2, x plus 4. For example, just anyhow. Okay, and then they tell you like f of x is equals to f of x plus 4. Find f of 5, find f21, draw the graph, find the inverse, that kind of thing. You must be able to do because it's very popular. Super popular. Okay, don't say number one. This is another one that is very popular, especially from people from messed up schools. You know who you are, don't need to say. Okay, so C part 2. Let's start with the range of h. And we know that this is h and infinity. 7 and infinity. And the domain of G is 1/3 and infinity. This is from the question. So the range of h is a subset of the domain of G. Therefore, GH exists. Last part, okay, before we take a short break, how do you do this? We find the domain of G first. This is 1/3 and infinity. The range of h is 7 and infinity. So this maps on. So now you know that your domain of GH is 7 infinity. Okay, sorry, I ran out of space. So 7 infinity. What you do, you draw this graph. And the graph looks like this. X equals to 1/3. Y equals to 1/3. Seven, 4/5. So what's the range? So the range of GH is just 1/3 excluded 4/5 included. Now, why is it excluded? Because this is an asymptote. Okay, and that's the answer. Oh, all this will be uploaded, so don't need to worry. Yeah. Dropbox. You notes, you flip second page, there's a QR code. I'll upload that. Okay, so we take a 5-minute break. Actually, wait, I'm running out of time. Are you okay with not having a break? We continue. Okay. Okay, but before we move on, anyone got any more problems? Yeah. Oh yeah, Rob. Thank you. Thank you. Better? Okay. Any more questions before we move on? The rest? Okay. Nice. So, next chapter, graphic. I want to do 1/fx. That's the main focus. Okay, so the rest are not the most important thing in the world, but still must be able to do. Okay, but can we focus more on 1/fx? For B, how do you get the new domain for B? Oh, it's based on your range of h. Okay, so now what I'm going to do, right? You can read through the whole entire notes yourself. Okay, what I'm going to do instead is I'm going to jump straight to a question and I'm going to show you how to plot 1/fx straight away. Okay, but before that, maybe you try. I want to see how you plot it first, and then we see. Okay, so can you all flip to page 25? 25. The details of the notes you read yourself. Okay, 25, the ASR question part B. Can you plot the 1/fx graph for me? Okay, you try first, then I show you the way that I do. Okay, the graph is on the screen, so please try 1/fx. Okay, so let's go through how to do this. Okay, if you're done and if you have nothing to do, the whole of question one, I do want the answer for you also. I want to go through the whole thing. Okay, so if you see me walking around, I will have told you the answer looks agak-agak looks something like this first. It's like that, asymptote, then like that. Okay, that's the answer. So I'm going to show you how to get it using this trick that I do lah. Okay, let's go. Okay, so we start off with B first, part B. So the way that I do it, right? Okay, what I will do first step is this. Instead of actually drawing the whole graph, I will draw a working line first. So I see a lot of people, you just write onto your graph. Okay, it's pretty much almost the same thing. Okay, but for me, I like to actually draw a number line out like this. Okay, this is not the actual graph. This is just a working on your piece of paper. Okay, and what I would like to do is I will mark out every single important point. So any intercepts, any turning points, anything that is important, you mark it down first. So in this case, the graph, -1, we see a 0 point, the y-axis, 1, I see a 4. Okay, so these are the quote-unquote important locations of the graph. Next, what I'm going to do is I'm going to write down whether are the values positive or negative. So it's a step-by-step process. So you can see that from -infinity to -1, the values are negative. So I'll write down negative. -1 to 0, the values are positive, 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 positive. So far, okay? So I repeat again, the intercepts there are just all the important locations. The negative, positive is looking at the values of the graph and able to see whether are they positive or are they negative. Now, the next thing I'm going to do is this. I'm going to draw arrows pointing up or pointing down. So the up and down arrows is basically just trying to tell you, is your graph increasing or is your graph decreasing? So what we do is start from left to right. We read from left to right. I repeat, read from left to right. Okay, so we read from left to right. So we start from left to right, we can see that the values are going down. Right? The x values are going down. So since the graph is pointing down, means your 1 over fx should point up. It's the reverse. Okay. Now from -1 to 0, the values are going down. So means it should go up. From 0.5 to 1, the values are going down. So means in your 1 over fx, it should point up. 1 to 4, the values are pointing up. So it should point down. And then from 4 to infinity, it's pointing down. So it should point up. It's just the reverse. And then the last thing is just to mark out, third step. Identify all the important points. What do they become? -1 is an asymptote. So this becomes an intercept, x-intercept. The 0 point here remains the same. So this one, nothing changed. The 1 became an asymptote. And this became a minimum point, 4, 1 over 8. Last thing is to identify what is happening to your corners. So I like to write it here. And the way to look at it is very simple. Look at your graph. This point here, you're heading towards infinity. Okay, heading towards 0. So this means what? 1 over 0 is going to head to -infinity. So that's why this part here will start from infinity, and you know it's negative. So it's -infinity. And for the right-hand side, you're heading towards 0. 1 over 0, same thing, is also infinity. So this one will go to positive infinity. And now we draw. So start drawing. We have 0, x-axis, mark out all the important points. So x equals to 1 is intercept, so -1. Asymptote here. Okay, so negative going up. Negative going up means like that. Positive going up means like that. Positive going up means like that. Positive going down means like that. Positive going up like that. And then label everything. So here, this is 0, 2. Here, this is 4, 1 over e. And that's your answer. Okay. So this is just a meeting lah. I usually teach people to draw this entire table out, and it will help to plot the whole entire graph. Okay, so we still have a bit of time. Can you look at question 1, part A, and then also part C as well? Okay, just give it a try, and then we'll go through. Part A and part C. Okay, all can understand how to draw. For those that didn't get it, all can get it. Okay, wait, sorry. One more thing I want to say. You notice that the question tells you that y equals to 0 is an asymptote, right? And it cuts the graph one time here. Is it correct? Asymptote, right? Should we be able to cut the graph again? So is it a typo? It's not. Okay, there's nothing wrong. Okay, you need to remember that horizontal asymptotes and oblique asymptotes can recut your graph again. There's nothing wrong with it. Yes, it's a fact. You can recut your graph in the center. It's just that the corners, they will be. That's why here's an asymptote, here's an asymptote. But anywhere in the center can just recut. It only works for horizontal and obliques. It doesn't work for verticals. That one confirm cannot.
真诚心对待真诚的。 Right.
If you want to check your answer, or anyone got an answer for this? What's the answer to the question? Y equals to, there are two versions of it. 1 over 3x squared minus 2x plus 1. Or y equals to 3 over negative 3x plus 1 whole thing squared plus 2. These are the two answers, possible answers for the question. Okay. So let's say if your this kind of transformation questions are very weak, there is a way to practice. You need to identify what to replace. So for example, what I like to do is to start from y equals to fx first, and then you do a replacement. You start with a. They tell you that a is a translation of 1 unit in the negative x-axis. So it means you take x and you replace with x plus 1. Okay. So you get y equals to f of x plus 1. Next step, v. This is a scaling parallel to the x-axis by a scale factor of 1 over 3. So means you take x, replace with 3x. You get y equals to f 3x plus 1. And the last one is step C. The question tells you there is a reflection in the x-axis, means you take x and you replace with negative x. So you get y equals to f negative 3x plus 1. So this is the whole process. So therefore, the final answer will be y equals to f of negative 3x plus 1, which is 3 over, replace it, negative 3x plus 1 whole thing squared plus 2, which you can expand. You get 3 over 9x squared minus 6x plus 3, which you will get 1 over 3x squared minus 2x plus 1. And that's the answer. Okay. What? Any problem? I got mirror image. Oh no, it's not. It's different. So the difference between the whole entire thing modded and the inside modded is different. The whole thing modded outside means you flip y up, right? Inside mod means you take whatever is on the positive side and you mirror over. That's the difference.
So this question is still on your
No, it's not. Yeah, just swap. Okay, just nice, right? Might as well just say, you know the tiny booklet? Okay, can you flip to page? I cannot remember which page. I think it's 13. You should see on the page there's a TSST on the page. You see it? page 13. I think it's 13, right? 12. Page 12. Okay, it's the page with the TSST. There's a typo on that page. Can you please change? Okay, you see this whole part. This is the whole entire transformation, right? Okay, on the Y side, if you look at your booklet, the tree that I circled here, on your booklet is X. Can you change it to Y? You get it? This tree only, not the last one. The last one you leave it, but this tree. Please change it to X. Please change it to Y. X is wrong. Okay, sorry for the typo. That is the only thing, that's the only mistake in this whole entire thing. I checked through everything else already. Okay, so this whole entire stack contains every single chapter. It doesn't contain, I don't think there's integration, and I don't think there is complex numbers. So for those schools that have already learned those two, that one don't have. But if you need it, you can text me. I have the chapters. Does it have complex? Don't have, right? Oh, we have integration, but no complex numbers. Yeah, no complex numbers. Right. Okay, because if I put complex numbers in, it will be 100+ pages already. Okay, so okay. Okay, and the last thing, okay, before we move on, what is complex numbers next year? You'll learn next year. Okay, last thing before we move on, okay, I want to say something first. So for this kind of graphing questions, right, there is a few types of questions that you should take note of. Usually the harder type of graphing questions, okay, is this part, which is the parts where they give you a gigantic huge equation, and then they will ask you to find your additional curve, find the value. Most of the time for a lot of people, if your math is very weak, this part will GG. Okay, so just be a bit careful. Okay, we still have a bit of time. So why not we practice one more 1/fx? Just for fun. Okay, no, maybe not. Let's do question 3. Can you try question 3? Then we'll go through the whole question. This one. Yes. If you got no time to finish the whole question, just look through first. Okay. Okay, so I've plotted the whole graph on the screen already. Okay, this should be the answer. So your C1 should be the blue color graph, and your C2 is the egg. Okay. So just to mark out some points, okay, because we're running out of time, unfortunately. So there's the one part, the very last part that I want to talk about. That one's more important. The graph sketching, this one, I should be able to do that. Oh, it should be symmetrical, huh? Okay, wait, it's not. Okay, it's not the most accurate thing in the world, but it works for now. Okay. It should be symmetrical. The x-axis should be higher. Yeah, I think it should be somewhere here. I think that's the better way to draw it. Okay, and then part C, find the x coordinates of the points where the two curves intersect. So this one I'll just give it to you. You can use your GC to check, or you can simultaneous, which I don't recommend. Use your GC to check. Okay, this coordinate here, the x coordinate is negative 1.19, and this value here is 1.19. Now, if you're wondering how do you use your GC to check the intersection point, right? You need to remember that your circle, your ellipse, you must use your conics app. Your normal graph must use the normal graph, right? Okay, but the problem is that your conics app and the normal graph cannot combine together. That's the problem. So what you do is you take your ellipse equation, you chop it in half. You find what is the bottom half of the ellipse equation, plot that into your normal function. You get what I mean? Because you make y the subject. Okay, maybe let's very quickly look at this. The ellipse equation is x squared over 9 plus y squared over 25 equals to 1. We make y the subject. So we get y squared over 25 equals to 1 minus x squared over 9. Y squared equals to 25 times 1 minus x squared over 9. And then you square root. Y equals to plus minus square root of this whole thing. 25, 1 minus x squared over 9. So the positive graph is the above the egg. The negative graph is the below the egg. So how to find the intersection point? Plot the below egg into your normal graphing mode. Plot the hypo into your normal mode. Find the intersection point. That's the easiest way to do it. Okay. And the last thing before we end the question, the inequality, which is the major part that I want to talk about. Okay, how do you draw the inequality? How do you solve the inequality question? Now, it's a hands question, so you need to use your graph. So let's look at the inequality. The question is negative 5 square root of 1 minus 1 over 9x squared less than equals to 2x squared plus 9 over x squared minus 4. Okay, so it depends on the school. Okay, some schools, they will purposely make the question very messed up, like very complicated. Certain cases, the questions are very nice. So what you should notice first is that this is C1. Pretty obvious. What is this? What is this random thing here? Now, if you have done it correctly, you will realize that this is just this. This is your C2. But what portion of C2 is this? This is the negative graph, which is the lower half. Understand? So this is the lower half of C2, which is here. So I'll highlight it out for you. This part here, can you see the yellow highlighter? This is the equation, and then so this is the one in yellow. So this part here, and the one in pink is this. This is this graph. Okay, now you need to understand what does the inequality mean. So just by logics of inequality, I want C1 to be bigger than C2. Means the C1 graph must be above the C2 graph. That's basically what it means. C1 above C2. Where? Where is it that C1 is above C2? Okay, it's between the portions. Let's use another color that I think you can see. So which portions will it be? It will be -3 to -2. So this part here. negative 1.19 here, this part. Okay, and then this part. Can you see the blue color highlighted part? These are the three sections. Maybe I darken it a bit more. Okay, but these are the three sections where your blue color graph is above the red color graph. Now, if let's say this section here is not convincing, you look carefully. Your blue color graph is here. Yeah, I'll try my best to emphasize this. The blue color graph is here. The red color graph is here. The blue is above the red. You can see it? Same thing for the other side. So it's just these three sections. So what's the answer for the range? It's just between -3 to -2, -1.19 to 1.9, 2 to 3. And those are the three answers. So whenever you're facing inequality questions, just trust me, look for the C1, look for the C2, find the graph, and then just see which is above which. That's one type of question. There is one more type, which is the ones that say, can you find the range of values of M given a certain equation? This one, I don't know whether if it, let me see if I have a question. Okay, I don't have. Okay, but within the other set of questions, I'll provide one. Okay, which is basically those that have like a big equation, there's a random unknown inside. Okay, for those kind of questions, there is a strategy to solve it as well. What you do is you need to identify what's the usage of that M. For example, sometimes the M will stretch your egg. Sometimes you will make the egg fatter. You need to identify what does that M value do to the graph. Then you see, okay, if let's say it stretches the graph, you see how much does it need to stretch by. Then you get your answer. How much does it need to elongate, shrink down, up, down, whatever. Okay, that's basically how to solve those kind of questions. Okay. Graphing usually very easy to score one. Okay, so this one should be able to do. Okay, sorry. So yeah, we only have 2 hours, so we don't have a lot of time. Fortunately. Try my best to do as much as we can. So, do you have any questions? Okay, so for me, right, personally, if you have any questions, you can just text. Okay. Okay, so you have if you can find me on Telegram, very easy to find. Just text me your question, just screenshot the question. I'll answer for you. Answer within like 30 minutes. You can get an answer. Okay, you don't need to be my own student, but I will still help you lah. Okay, I'm okay with it. Okay, so if you want to find me on Tele, you can find me here. Okay, this is my handle. Okay, just text me. Yeah, ask anything you want. Okay, it doesn't need to be just these topics. J1, J2 topics, all can. Anything also can. Okay, but of course only math. You don't ask me Chinese, you cannot expect me to help you. No way, it doesn't work that way. Okay. Okay, last thing. Okay, okay. Okay, last thing, I just want to say one thing. Okay, so we hope that you enjoyed the session. Okay, I understand a lot of feedback so far is that the session is very short. Okay, of course, no choice lah. JC is like that. Okay, so for me, I'm opening classes for next year. So if you want, you can always look for me. Okay, I primarily teach here and Parkway Parade. These are 2 places. But I also teach in the West lah. So if you want, you can always look for me. Okay, last thing, feedback. So we want to know how I've done and want to know how can we improve the sessions for next year. Okay, so please help with this QR code. Don't click the wrong name because there are 3 people that are teaching math. My name is Kaiwan. Okay, use the correct name. Can be as honest as you want. Yeah, because I won't read it. So. Okay, so I'm going to stop sharing. Okay, then for those on Zoom can join. Thank you.